Hi everyone, I made this Christmas tree light as a small holiday project and I'm really glad with how it turned out. Look, it's even got Christmas lights in the tree, although most of them are covered by the snow. The best part about this project is that it has swappable scenes. I like to call them scenic cartridges. You can easily swap one out for another. If you want to support my work, don't forget to like, share and subscribe, and make sure to stick around until the end of the video. This version has an internal battery, but it also comes with a docking station that can either charge or power it directly using a wall adapter. To start this project, I designed every single part in my 3D design app and printed them out. One of the main goals for this project was to make the Christmas tree look as natural, realistic and beautiful as possible. Because of that, I didn't want to use cheap, off-the-shelf plastic miniature trees. So I decided to make one myself. I started by cutting a manila rope into smaller pieces and then separating the individual fibers by hand to create the pine needles. Next, I dyed the fibers using a mix of water and acrylic paints, coloring them in 3 different shades of green: a deep forest green, a lighter green, and a very light lush green to add variation and realism. After dyeing the fibers, I spread them out on a piece of paper towel and let them dry completely before moving to the next step. Next, I ran the fibers through a grinding machine, turning them into super fine, hair-like strands for a more realistic texture and also better adhesion. For the tree trunk, I 3D printed a small tube with holes on either side. I fed optical fibers through the holes in the tree trunk, bringing them out at the base to set up the foundation for the Christmas lights inside the tree. I used hot water to soften the optical fibers, which let me bend them into the shape I want. Next, I used a blowtorch to melt the tips of the optical fibers into tiny balls. This makes them look like real Christmas lights and lets the light spread out beautifully instead of shooting out as a narrow beam you can barely see. Next, I mixed black, red and a little green acrylic paint to create a dark brown color and used it to paint the tree trunk for a realistic look. Now it's important to paint the base of the optical fibers leading up to the tips. This way only the little balls at the ends light up, instead of the whole fiber glowing. Here I used a small drill to make the tiny holes in the tree trunk for the branches. Be careful not to drill too deep or you could damage the fibers. I cut thin, stiff copper wire into smaller pieces and glued them into the holes in the tree trunk to act as the branches. In the next step, I added super glue to the branches and stuck the fibers onto them. Make sure to use different shades in different parts of the tree. This creates a beautiful color variation that makes the tree look much more natural and realistic. Next, I sprayed the tree with resin spray to lock the fibers in place and make sure the colors stay vibrant for a long time. Once the resin is dry, I use scissors to separate the branches and shape the tree, giving it a fuller, more natural look. Now for the scenic cartridges, I 3D printed these ABS rings and coated them with resin spray to make sure they are completely watertight. The water pump consists of the housing, a separator, the impeller, and the magnet ring. I also salvaged the shaft and the bearings from these small DC motors. To drive the pump without direct contact, so you don't have to worry about waterproofing a shaft, I used a magnetic coupling. It has 4 magnets arranged with alternating polarity, so each magnet is opposite to its neighbors. It's really important to glue the separator carefully, making sure it doesn't touch the magnet ring below or the impeller on top. Take your time here and adjust everything precisely. This will give you a smooth and quiet operation. When everything's done right, the system should be so smooth that you can spin the impeller just by bringing a metal object close to the magnetic field. Use silicone sealant to seal the gaps and make sure everything is watertight. This is the top bearing bracket. I heat pressed the bearing into it using a soldering iron, and this part fits right into the intake hole at the bottom of the cartridge housing. I use these silicone tubes to transfer the water from the bottom to the top, using plenty of silicone sealant to make sure there are no leaks. The cartridge housing for the tree has a small port on the side that lets light pass through to the optical fibers, lighting up the Christmas lights. To set this up, cover the other side with tape, fill the cavity with clear epoxy, and insert the ends of the optical fibers. This way, light shines into the fibers and travels all the way to the tips of the lights, giving the tree that magical glow. Now you'll see where the light comes from later in the video. After installing the bottom bracket, which both holds the tree and allows snow and water to pass through, cover the 2 top LED ports from underneath with tape. Use 2 warm white LEDs to light up the entire scene. Fill the LED ports with clear epoxy to seal them and keep everything waterproof. The LEDs are wired with a common ground. And then use silicone sealant to seal their backside too. Making the light pole is really easy. It just has a few 3D printed parts. Be sure to add silicone sealant inside the LED holders to protect them from water. And then cover the tops of the LEDs with clear epoxy. This both seals them and lets the light shine through beautifully. It's also a good idea to fill the internal cavity with silicone so that it's even more waterproof. The bench is also pretty simple. It just has 4 3D printed parts which you have to glue together using super glue, and that's it. Then I glue all the parts to the bottom bracket, the same as the one with the Christmas tree. Now gently straighten the light pole wires, line them along the inside wall, and glue them in place. The wires come out through a hole at the top, which you'll need to seal with silicone sealant. This piece acts as a spreader. It distributes the incoming water and snow evenly over the 2 holes at the top of the cartridges. I also added a small piece of silicone tubing to make it easier to fill up later. Next, I glue the tube coming up from the pump directly to the spreader, connecting everything so the water and snow can flow smoothly. The dock is made up of 3 main 3D printed parts. I also added a 5-volt regulator as the power supply, which I glued onto a thick layer of aluminum tape, stacked in multiple layers to act as a heat spreader and heatsink. The alignment pin has 2 parts, the bracket and the pin itself. Before gluing it onto the base, I added a small magnet at the bottom to help keep everything secure and aligned later on. On the other side, we have the connection pins. It's made up of a bracket, and I'm using 2 battery connectors from old mobile phones to make the connections. After soldering wires to the pins and gluing 4 magnets to the corners of the bracket, we can glue the entire assembly in place. Here I also glue in the smaller alignment pin on the other side. To control everything, I'm using a two-way 6-pin switch for the dock. I started by putting tape on the other side to hold the switch steady while I'll glue it in place. Next, I added two small pieces of paper on the sides of the switch to keep glue out, and then filled the side cavities with black glue for a clean, secure finish. Next, I glued in two status indicator LEDs and filled their holes on the dock with clear epoxy so the light shines through beautifully. Now you can install the DC power jack. You could also go with a USB Type-C port, and if you do, you don't even need the voltage regulator. After wiring everything according to this schematic, I sealed all the electrical connections with silicone and filled the entire bottom of the dock with white cement to give it weight and extra sturdiness. After the cement is set, you can glue in the bottom plate and seal everything up. So I've already shown how to make DIY PCBs at home in my previous video, so I'm not going into detail here, but I'm using the toner transfer method. After making the PCBs, it's time to solder all the components in place. Starting with a 3-volt relay, a flyback diode, 150 ohm resistors, the capacitors, two general purpose NPN transistors like BC547 or similar. Just be aware of the pinout. A potentiometer to adjust the speed. (39 kilo ohm resistors). And a 2.2 kilo ohm resistor. Here's the circuit diagram. It has two main sections, a switching section to turn everything on and off with an incoming signal, and an astable multivibrator circuit that makes the Christmas lights flash. Keep in mind that the pump motor connects directly to the relay's output. Here's the main housing. It's a single, seamless 3D printed piece. I start by gluing in the microswitch that detects the presence or absence of a cartridge, stopping the system if there's nothing inside. Remember those tiny PCBs I made earlier? Those act as the connection paths for the docking station. I also added a small wire to the back so I can bend them into shape and then glue them in place. Start by aligning the PCBs with the dock pins and bending them into the perfect shape so they make a solid, reliable connection. Then glue them into their designated spot on the main housing. After soldering thin enameled copper wires to the pads, cover the back with a small piece of tape, then fill the entire cavity around the connection pads with epoxy to secure and protect everything. Here's a diagram showing exactly how everything is wired inside the main housing. I've also marked where each of the microswitches goes so you can see the full layout. For instance, this is the switch number 1. It should be installed in a way that the alignment pin from the docking station presses it down. And here are the battery and the charging board. The charging board should have a DC input in addition to a USB port. Align the charging board with the USB cable and glue it in place. Only the Christmas tree cartridge has this small pin that presses down this switch to activate the flashing LEDs for the Christmas lights. Now to turn the device on and off, I'm using one of these touch switches. I like to remove the indicator LED on the touch switch so it doesn't light up the whole plastic. Also, if your touch switch has multiple modes, make sure to set it to latch mode. These are the LEDs and bracket that light up the Christmas tree's optical fibers. Just glue the LEDs in place and connect them to the control board's output. You can really see how the transparent, resin-filled part of the cartridge aligns with these LEDs, lighting up the optical fibers. Next, I glue these side panels onto the cartridges. They hold the tubes in place and also press down on the side switch inside the main housing, letting the system know a cartridge is inserted. I had the glass panels cut professionally since I don't have the tools to do it myself. Make sure to clean and disinfect the inside surfaces before installing them in place. To drive the pump, I'm using the motor from a small high-speed DC brushless fan, and I'm using the same magnets from the impeller side for the magnetic coupling. Now it's time to glue the side panels of the cartridges together. One panel has a small indentation for a tiny PCB connection board, which I glue in place. Then I use the main housing to align everything and glue the panels together. Next, I install a pair of powerful neodymium magnets in the main housing and a matching pair inside the cartridges. This way, when you insert the cartridges, they snap in and stay securely in place. Then I soldered the LED wires to the connection pads. These make contact with these pins inside the main housing powering the LEDs. I also added optical fibers to the charging board LEDs to guide the light out of the housing. Plus, the fan motor is powered by a 12-volt boost converter to make everything run smoothly. I then glue in the front part of the main housing. After filling up the cartridges with a mix of distilled water and snow particles, and snapping on the top cap, they're good to go. This thing is truly mesmerizing to watch. The best part, it can run up to 2 hours on battery power. Plus, the docking station lets you either charge or power it directly from the mains. This swappable design is also super flexible. I'm already thinking of making different cartridges, like a windmill. Maybe if this video gets enough love, I'll make that one in a future shorter video. Thank you so much for watching. I'll see you in the next project.